In this lecture, we're going to talk about systems and their surroundings. Now, a system can be defined as simply our object of interest. The thing that we're studying is called our system. And everything outside our system, everything that we're not studying, that is not of interest to us, is called our surrounding. Now, system plus surrounding will give us our universe. So for example, if we take this water bottle, and this water bottle is our object of interest, the thing we're studying, for example, we're studying the motion of this object as it's traveling down from above, we say this object, the object of our interest, is our system. And everything outside our object, say the air molecules in this room itself, the building, the earth, and in fact the sun and stars and everything else in the universe, besides this object, is our surroundings. So, once again, a system can be defined as any area and or object of interest. And everything else that we are not studying is our surroundings. Now, there are three different types of systems we can study: open systems, closed systems, and isolated systems. So let's begin with the open system. So open system is a system that allows for the exchange of both mass or matter as well as energy with the surroundings. So an example of an open system is an open container or an open water bottle. Why is it open system? Well, because air molecules found on the inside of my container are allowed to leave my container, my system. And that means air molecules in the air are also allowed to enter my system. So mass is exchanged because molecules which have mass leave and enter the container. Likewise, energy is also allowed to exchange. If I put this under a flame, the energy will transfer from a higher to a lower. And that means this object will gain energy. Now, a closed system is a system that allows the exchange of energy but does not allow the exchange of mass or particles. For example, if I take this container and I seal it shut, I create a closed system. And that's because now my molecules will stay within the container, within my system, and they will not leave the system. Likewise, no molecules from the outside, from the surroundings, will enter my system, will enter my container. But once again, if I put this under flame, the air molecules inside will gain kinetic energy because energy will flow from a higher temperature to a lower temperature. And that means this system will gain energy. So energy is allowed to exchange from system to surroundings, but mass is not. There's also something called an isolated system. An isolated system is a system in which no exchange of any kind occurs. No mass is exchanged and no energy is exchanged. And an example of this is our universe. Now, according to the law of conservation of energy, this law states that the total sum of all the energy in the universe in an isolated system remains constant. That means if we sum up all our different types of energies, the potential energy and a kinetic energy, our sum will remain the same. Now, if we take the universe once again to be the isolated system, this law does not state that energy cannot be converted. For example, we can convert all the energy, all the kinetic energy to the potential energy, but the total amount of energy will remain the same. So kinetic energy plus potential energy will give you the total amount of energy.